I am Dr. A.S.R. going to teach you about quantum computing. Here there are two. One is quantum computing, another one is quantum technology. So both are related to quantum computer. Now see the difference, quantum computing and quantum technology. Quantum computing means we are going to work on quantum computer, writing programs and executing the programs. Just we are going to use it. That is quantum computing. Now coming to the quantum technology. This quantum technology related to hardware of the quantum computer, means how you are going to build the quantum computer, means technology difference. That's why we are calling quantum technology. Understood? Now we are going to start with the quantum computer. Before going to the quantum computer, just to have some basic knowledge about computers. Now what at present we are using computers that we call as a classical computers. We are using now at present what you are seeing that are classical computers. Now we are moving from classical computers to quantum computers. Still, these quantum computers are not available. Still research is going on. Understood? Now, why we require these quantum computers? Because whatever we are having present computers, that is not that much fast enough. And these quantum computers are millions of speed when compared with the classical computers. That is the reason all are eagerly waiting for quantum computers. For example, if you want to solve any complex problem on classical computer, for example, it will take 10 hours. To solve one complex problem in classical computer, it will take 10 hours. And the same problem can be solved in quantum computer within seconds. Within seconds, maybe milliseconds also. That much fast. That is the reason all are eagerly waiting for quantum computers. Understood? Now, coming to the main concepts about computers. So, computer is an electronic device. Computer is an electronic device which will do arithmetic and logical operations. Computer is an electronic device which will do arithmetic and logical operations and gives the result. So further, we have to give some information to the computer, to the electronic device. Understood? For example, if we are going to give 2 and if we are going to give 3 also, and this will make, if we will tell to the electronic device do addition, then what will happen? It will do 2 plus 3 and gives the result 5. Understood? This is the computer. Now see what is there in this electronic device. And let's say this is input, which we are going to give the information to the computer, and this will be the output. This result will get the result. Understood? Now, this electronic device consists of electronic components. For example, say like this, for example. It depends upon how many. Okay, that I will explain later what it is. So, group of electronic components together will make an electronic device. Now let's see what is this component. What is the component? That is electronic component. It's look like a switch, electrical switch. Let's say this is electrical switch. Similar to electrical switch? Hope so. Okay. Now this is the switch, electrical switch. Now it is in on. If we make it on, then lights will on. If we make it up, then it will be the off. Understood? Switch on, switch off. If you want to make a light or fan should be on, then you are going to put on state. If you want to off the both, put it on off state. Just you are going to press up, so that will be the off. That is our understanding language, that on and off. Can switch can understand what is on and what is off? No. What is inside the switch? All mechanical, electrical. Means current is coming to this switch, electricity. If it is on, means it is going to connect this. Means electrical switchboard sending the electricity to the on state. It is going to connect, then light will be on. Then it will be the, if you want to off, and this connection will be disconnected. Like that. This connection and this will be the disconnected. No connection means off. That only this switch can understand. So these two, as it is a 0 and it is 1. Means 1 is connection like a on. 0 is disconnection, means off. Or maybe it will be 1 or 0, whatever it may. Only two states, 0 or 1. Understood? Now, can you make the switch both on and off? No, we are not going to use both at a time. Am I right? Either on or off, any one state. Understood? Only one, either on or off. In computers, what you can say, either 1 or 0. Not at a time, both. Got it? Just remember the concept. Now, whatever we are using, zero and 1, This is understandable by the electrical switch or electrical electronic component. Understood? So this one we call as a bit, and this also we call. So any number we call as a bit. If you say bits means 0, 1 bits. Understood? Now this way only we can give information to the computer, because computer understands only zeros and ones. Got it? Now, if the electronic device having like these 4 switches, means 4 switch. Understood? This also, let's take 0, 1, 0, 1, 0, 1, 0, 1. Understood? We are using 4 components, like 4 switches in a electronic device. What is the capacity of this? 4 zeros or 4 ones? Depends. If you are going to use 50 switches, that will be the 50 zeros and 50 ones. Understood? So these are the, now we are using 4 zeros or 4 ones. So total 4. So we call as a, this is 4-bit computer. This is size. Understood? If you are going to use 16, then you say 16-bit computer. At present, classical computers are available 64-bit. Got it? It means 64 switches in this. Means 64 zeros to 64 ones. Understood? That is the size of the computer. Maybe it is moving towards to 128 bits computer. Means totally 128 switches we are going to use in this electronic device. Got it? Means 128 zeros to 128 ones. Understood? So this is the size of the electronic device or classical computer. So here what you should understood, it will take only 0 or 1, means only bits. At a time it will take only one value, either 0 or 1, like a switch on or off. So depends upon the switches or components we are going to use in the electronic device. That is the length of the system computer. That is, for example, say 64 switches, we are using 64 zeros or 64 ones. That is the size of the classical computer at present what we are using. Understood? In the last class, we discussed about the classical computers, which uses bits, either 0 or 1. Only one value it is going to take. And this classical computer will work simultaneously or step by step. But we know already. Now coming to the quantum computer. Here also computer. Computer means only it will work on zeros and ones. Understood? So here also we can write bits. So it is also 0 and, but here it is, here we can say as qubits. In quantum computer we are going to use qubits, like bits in classical computer. Then what is the difference between bits and qubits? Here bits in classical computer only it will take one value, either 0 or 1. Understood? Now here qubits, this quantum computer takes qubits either 0 and 1 with both values or combination of zeros and ones. Means it, quantum computer will take both values 0 and 1 at a time. Understood? So multiple values. Understood? Here is single, only one, either 0 or 1. Here multiple values. Means it will take 0 value and 1 value. So it's taking multiple values. Understood? Means it will work simultaneously. Sorry. It will work as sequential or parallel. Because of taking multiple values, it has to process on multiple values. Understood? So sequentially it is going to work or parallel it is going to work. Here only single value, that's why step by step. First it will take 0 value and next it will take 1. Step by step. Here multiple values taking means multiple steps it has to means parallelly it has to be done. Understood? That is the difference between qubits and bits. Now, if you take a computer quantum, it will take two multiple bits. If both will go inside. Now see, already we discussed about the computer. In computer there are components. Each component will work on 0 or 1 only, like on or off. Then what about quantum computer? How the components will work? Means it has to work on 0 and 1, once on or off, both at a time. How it is going to work on that? Can you make switch on and off both at a time, on and off both at a time? Normally we can't do this, but here in quantum computing we can make on and off both at a time using mechanical principles. Then we'll get the output. This is input 0 1, both will take inside. Here components will work based on mechanical principles. That is the reason it can take multiple values. Here there is no mechanical, only physics based. Only components they are working on voltage or charging. The state is like that. But here the same components, electronic components in this quantum computer will use or apply mechanical principles. Understood? What about mechanical principles? I will explain next. Understood? So remember this topic, most important, qubits and bits. That is the difference between classical computer and quantum computer. Hope you understood.